Yeah. Hello class. Yeah, it's another session, and we are trying to move on with topic 7. Topic 7. Now, we have gone so far through 6 topics of Senior 1. Now today, we are looking at the 7th topic. And topic 7 is air. Topic 7 is air. Air. Now, under air, there are also subtopics like meaning of air. Meaning of air. So, then the components of air. Components of air. So, then we shall also visit uses of various components of air. Various components of air. The topic is very short. So, and we shall also now visit air pollution. Air pollution, because you can't talk about air without talking about its pollution. Before air pollution, we should first look at separation of components of air. Components of air. Then air pollution. Air pollution. Air pollution. Now, let us start right away from the components of air. I mean meaning of air. Meaning of air. In the previous topic, we saw that air was a mixture. Did we see so? Yes. We saw that air was a mixture of what? Gases. Mixture of gases. Now, the word to be a mixture of gases makes air so big that we can't limit air to a room. See? Now, in other words, air is the atmosphere of gases. See? The atmosphere or the mixture of gases. Now, seeing here that indeed this air is what is around us. Is that so? Air is what's around us, and what's around us is the atmosphere. Of course, the definition of the atmosphere is that the atmosphere is the air around us, meaning air is the atmosphere of gases. See? So, now, the atmosphere, the word atmosphere is now, it brings the idea very big. See? That our atmosphere here extends way down from the Earth's surface up to beyond, so up to beyond the clouds until it goes past the Earth itself. Now, the atmosphere is what we mean by air. When we talk about air, we are talking about the atmosphere. And indeed, our atmosphere is really divided. Our atmosphere here extends from where we are through many miles in air, and indeed the region of the atmosphere in which we stay in, see, is called the troposphere. That we stay in the troposphere. The atmosphere is now, you see, it starts from here where we are, goes up beyond until you reach the sun. And the other layers of the atmosphere or other layers of air include the stratosphere. That means the atmosphere has now categories there. We stay in the troposphere where we are now. The lowest part of the atmosphere is the troposphere. See, we go into now the mesosphere. Now, then takes us to a very high region there called the thermosphere, which region helps in the transmission of radio sounds. See, the troposphere and the ionosphere. Of course, you must know this if you are talking about the atmosphere. Then you have the exosphere, and finally, outside the Earth, when we leave our Earth's surface, then we are enjoying another section called the magnetosphere. For us, we live in the troposphere. See. Just a few kilometers, you reach the stratosphere. See? Yeah, now that is your air. Now going very fast, that means we've talked about what air means. Air simply means the mixture of gases or an atmosphere of gases. See? Now taking us down to another subheading here called the components of air. Yeah, now there are components of air. That's your part now. Components of air. We've said that now what do we find in the atmosphere around us? What do we find in air? See? Yeah, let me hear from you. Yes. Aspolo, what are the components of the atmosphere or the air? It is composed of nitrogen. Yes. Oxygen gas also there.
Carbon dioxide.
Carbon dioxide. Or carbon, then space. You leave some space, dioxide. Yes. Then rare gases are part of that. Pollutant gases are also there in that atmosphere, including dust. See? And dust. What else? Water vapor. Water vapor. But remember that they only carry a small portion of the earth. These are very, very tiny in the atmosphere. Why? By nature. See? It means if you are not very important, you can't be made a lot in nature. See? How much is it? Could we have somebody with any information about the percentage compositions? The volume, the percentage volume of nitrogen. Yes, question. 78%. Then this?
21%.
21%. 0.03%. Then?
Yes.
The balance is 0. What?
There is also a gas there is 0.97.
0.97.
No, rare gases.
Have 0.97. Does it leave any value or it finishes everything? Are you sure?
Yeah.
If it's 97 here,
it finishes all.
this 93, so that the balance is now this. That's roughly 0.0. 0.07? Around 0.04. Yeah. That means basically your atmosphere is less with pollutant gases. But these days they are increasing, as we shall see in the air pollution. See that we are no longer breathing in very, very fresh air. See. Now, let us jump very fast here to the uses of each component there. Each component there. Uses of each component. What are the uses of this nitrogen? Nitrogen on Earth, they use it for what? Oxygen, used for carbon dioxide, could we have some uses mentioned by somebody? What is the use of nitrogen gas here? You might be having prior knowledge from primary level, not so. Yes, as Paul.
Nitrogen is basically the manufacture of fertilizers. Yeah, manufacture of fertilizers. Then, yes, patience.
Nitrogen can be used by plants. Some plants which have nitrogen fixing
Bacteria. Used by nitrogen, used by plants. It's fixed by plants, fixed by bacteria as a nutrient. As a nutrient. Hospitals use it for what? Hospitals use it for? Those who has ever eaten crisps? Yeah. Crisps from supermarkets are kept fresh. You see, the presence of oxygen anywhere causes what we call the bacterial decay. That respiration in primary you called it aerobic what? That aerobic activity, the bacteria reacting on some substances in the presence of oxygen. Oxygen is very, very dangerous. It is good, very, very important, but again bad in the preservation of items. Like it would leave, food wouldn't stay for a long time. But how they preserve foods is that they normally add they remove oxygen from the container and introduce their what? Nitrogen. So because nitrogen can't support action of bacteria in foods. So that means it is used to keep packaged foods fresh. Not very, very right. Yeah. Now oxygen here would do what? What's the use of oxygen? Those are many, I think you have them. What are some of the, yes, Aspolo?
Respiration.
Oxygen is used in?
Respiration.
Respiration in what? Respiration in animals. Is it used in respiration in plants? So, go ahead. Yes, patience. Supports burning, meaning it's used in conducting burning. What else? Conducting burning, conducting. What of in this COVID era, what did the oxygen do? So, I heard people complaining about oxygen. What was hospitals to support life where people can't breathe easily, normally, or breathe normally. Support life in difficulties of what? Breathing. Difficulties of breathing. Okay, run to carbon dioxide here. Carbon dioxide in fire extinguisher. What else?
Total drinks.
At preserving fisher drinks like soda. See. What else is it used apart from preservation of fisher drinks? Used in the plants for respiration. So, for respiration. Okay, thank you. Now, what could rare gases have some uses? Do they have? Of course, what are those rare gases? Can somebody give us a reminder of which rare gases do we have here? Yes, patients begin mentioning them. Neon. Do you know its use? Neon mention. Go ahead. Argon. Xenon, krypton. What is the use of neon? Bulbs. Helium. Bulbs used in what? Used in which bulbs are those? This bulb having neon. This energy saver. Used in which bulb? So, electric signs. Those you see those lights in the salon, which flash red, blue, white. So, argon is used in those bulbs which are hot, not energy savers. Do you recall those bulbs which had the filament inside? Which were really hot in the house when you put it very hot. You see, one time I learned about energy savers and their effects because they use some mercury inside, and mercury is dangerous. I decided to remove an energy saver from my room and bought this, and bought a tungsten bulb. But every, I think, 2 weeks you must replace. And the room is always very, very hot. You see, so argon is inside, and argon helps out that the filament would burn. If there was no argon, it would just burn off and explode off, melt, and have nothing. Argon is used in those tungsten lamps to prevent the melting of the tungsten. Now xenon are those flash cameras. Those flash cameras use xenon. Light of very high brightness is that xenon and krypton. Helium, those helium. Who was any use for helium? I think you've watched those people moving in balloons in air. A big balloon. Have you watched those? You might be deceiving that you have never watched that. But they are used in balloons, filling balloons. Those balloons which are used to carry people in air. Now let us go to separation of the components of air to save time. Now we say that first in the separation of mixtures that fractional distillation is indeed used to separate these components, not so? Yeah. Now there, I would request for a reason why we separate air using fractional distillation, separation of components of air. How do we separate the components of air? In our method there, patients, you want to remind us how we separate air and the reason behind that.
We separate air using fractional distillation.
Fractional distillation.
And this is because fractional distillation is used to separate substances with different boiling points.
Different boiling points. That means these gaseous components have different boiling points. See, indeed nitrogen boils at negative 189, oxygen boils at this is 196. You have that table, that fractional. Let me give you that chart for separating so that you will quote for me the correct figures here. Yeah, you can have this fractional distillation plant for liquid air. Patients, point it up here how you separate those components, that plant there, the different boiling points here. You can read them for us. Patients, see?
Nitrogen is negative 196.
196.
Liquid solutions.
180.
Then argon is negative 186 degrees solution.
Negative 186.
Then oxygen is negative 183 degrees
83.
Krypton is negative 153 degrees solution.
Negative 153.
Xenon is negative 108 degrees.
108.
8.
Only that?
Yes.
Okay. Now listen. Listen very, very well here. Listen. These are values behind there. Now, listen here. The plant, you see, this we can't do it in the laboratory, of course. It's not ideal. Because even collecting air is not even easy. See, we can collect very, very little to get what we want. Now listen here. You heard of oxygen manufacturing plants. In the COVID situation, you heard that Uganda had run short of oxygen. And the plants which were making oxygen were what? Were making little than it was being absorbed. Now look here. When they want to separate air into those components, what do? The air is first converted into a liquid. Because fractional distillation works on liquids with different boiling points. The air is first converted into a liquid, but in the conversion into a liquid, carbon dioxide and water vapor, because air contains carbon dioxide and water vapor. Carbon dioxide and water vapor are first removed because, listen, because in the struggle to convert air into a liquid, for them through the pipes, they easily change. You see, these temperatures are very, very low. These negatives. This is coldness. See this. This is coldness. See that? Negative is below zero, not so. See that? That means you can now carbon dioxide and water vapor are first removed because water will freeze at zero. That means when you are trying to pass the air in the pipes, water will have frozen and blocked the pipes already. Before they convert air into a liquid, they first remove water by passing air through some drying agents called silica gel. Then carbon dioxide, being that it also turns easily into a liquid and a solid finally, is also removed by passing through another chemical called sodium hydroxide. Then they will be left with nitrogen, oxygen, argon, xenon, krypton, helium. See that? Now, the rest are now converted to a liquid. The rest are converted to a liquid. Now look here. I'm giving a small illustration here that you need to really follow. Need it really follow very, very, very well here. Now look here. This is your source of air. Air is here. Now, that air, you first remove carbon dioxide and what? And water, not so?
Yes.
Water vapor. Clear? When carbon dioxide and water vapor have been removed, it's now allowed to enter. It's now allowed to enter a what? A compressor. See? Now listen. The air is compressed. Because to make it a liquid is to bring the particles closer. The air is compressed. After being compressed, it's allowed to expand. When it expands, it cools. Some of it gets to a liquid and enters the fractionating column. Some of it is recycled back. Now let me first speak something there. Whenever a gas is allowed to expand into an empty space, it cools down. It cools down. And by cooling, it can turn into a liquid. Now when it turns into a liquid, it enters the fractionating column where it is subjected to heat, and finally the different components are separated. Okay, leaving that section alone, let us turn to air pollution. Air pollution, we are trying to keep time. Air pollution. Now, under here we are going to define it. Definition of air pollution, signs of air pollution, what shows that air is polluted. Then we look at causes of air pollution. Then if you know the causes, what are the effects of air pollution? What is the effect of air pollution? Then how can we eliminate air pollution? Eliminating or eradicating air pollution. How can we control air pollution? Now what is it? Let me pose this discussion to you. What is to pollute? What is air pollution? Let me hear from one of you. What is air pollution? Yes, patience, help us there.
I think air pollution is the adding of dangerous or toxic substances into the air.
As simple as that. The substance must be toxic to who? Soil?
To the air and
To the people. Living organisms, not so? Yeah, thank you. Air pollution is the introduction of harmful substances into air which are harmful to all living organisms. Thank you. What are the signs that air is polluted? Signs of air pollution. I think let me leave you to discuss those signs. You give them to me. I need only 3. What are signs of air pollution? Also discuss causes, discuss effects. Signs of air pollution, causes of air pollution, effects of air pollution. We are through. Thank you very much. Now, whom do we start with to present, because we have here so many things. Signs of air pollution. Who is ready? Yes, we start like this. Patience, discuss signs of air pollution.
We have change in order and change in color.
Yeah, change in order. Order. Order, what's order? Smell.
Then change in color.
Change in color and order. Then, only that?
Yes.
Okay. Have we exhausted this one? Signs of air pollution. Eh? Yeah. What of the feeling? Can't you feel anything as an animal? Maybe eye irritation, respiratory problems, difficulty in breathing. Can that indicate?
Yes.
That means you can have some respiratory. What of allergies? Allergic reactions. Could that be so? Change in color and odor would be a sign. Respiratory problems. That means you'll find difficulty in breathing. Then allergic reaction. Many allergies, people have allergies these days. It's because of these pollutions. Air is no longer natural. Eye irritations. So this man one time had an eye problem. That's it. Did you? You said your eyes are resistant to what? To bright light? This is eye irritation. Even the ears and so on. Those are all signs when you don't breathe well. So when you feel the eyes are scratching you, because you see these gases like ammonia. We shall see those pollutant gases and you'll see. Okay, that's all. Signs of air pollution: one, change in color and odor, respiratory problems, allergic reactions, eye irritation. Okay, then causes of air pollution. Yes, Juko, what are the causes?
Industrial fumes.
Industrial fumes. Industrial fumes. Then?
Car fumes.
Car fumes. Car exhaust fumes, not so?
Then fumes from burning substances like tires.
That means fumes from burning materials. What else? Only that. Are there some natural causes of air pollution? Haven't you ever heard of volcanic eruption? Those are natural calamities. Natural calamities like the forest fires, fire catching in the forest, like because it's very hot. That's scientific. Yes, how about what? Hey, you call it, how do you call that one? Somebody gassing, you call it like that. Forest fires.
About if something is like rotting,
does it emit bad gases?
because now in the place and you feel some place.
Could we call it household activities like rotting rubbish?
Like the garbage pit.
Household activities. These are caused by man, also. Like rotting rubbish. What else? Or even smoking, not?
Yes.
Those are all household. Smoking. Those are all causes of
Even
pollution.
use of some chemicals. Like
Use of some chemicals. That means fumes from laboratories. Not so? Fumes from laboratories. Okay. Is that correct? Fumes from laboratories. That's right. So, even some electric power stations, they burn and produce this smoke. Yeah. So power, we have them as now. That is a very big point here. Causes of air pollution: industrial exhaust fumes, car exhaust fumes. Clear. Now, what you should notice here, listen, any machine or plant that uses fuels like petrol, diesel, all those are called fossil fuels. Now let me first dwell there as we go to pollution. Fossil fuels like coal and petrol. So now coal is a rock. Coal is a rock that is containing a mineral called coal. That coal has basically carbon in it. Its major element is carbon. Petroleum is a mixture of many hydrocarbons, substances that have carbon and hydrogen. And all this is what our machines use as fuel. And burning any fossil fuel liberates very poisonous gases. That gases produced from fossil fuels here are carbon monoxide. This comes from vehicles. If a vehicle is burning its smoke in the exhaust pipe, don't run there, because some of you say it is smelling nice, not so. Carbon monoxide is coming from the car engine because there is limited oxygen in the car engine. It is embedded inside. They are burning occurs in the engine, liberating this poisonous gas, very deadly. When you inhale it, see, there is no way you can reverse the effect because it will go and mix with the hemoglobin and make it unable to transport oxygen. Therefore you will die. Also, some sulfur dioxide gas also comes out of these fossil fuels. Very, very dangerous, poisonous, causes eye irritation. Sulfur dioxide gas. See, There is the oxides of nitrogen also that come from here. See, fossil fuels. Now, turning here, effects of air pollution. Let's have Aspolo taking us through that, effects of air pollution.
It leads to respiratory diseases.
Yes, respiratory diseases. Respiratory diseases like smoking, it does to you what? Lung cancer, not so? What else?
Allergies.
Allergic reactions, increases allergies.
It also leads to suffocation.
Suffocation. That's respiratory problem.
Suffocation leading to death.
Why don't we put it as a respiratory problem, e.g. disease or suffocation? So now, what is that only? What happens to our rain when those gases come into it? Now those gases are acidic, like carbon dioxide and sulfur dioxide. They lead to acidic what? Rain. And any acid in the rain damages what? Plants and buildings. See, because there will be a chemical reaction between rain and the chemicals in the building. We saw limestone, which is calcium carbonate. See? Oh, that's very, very correct. What are some of the effects? Are they the only ones of air pollution? Now, let me ask, who has heard of global warming and greenhouse effect? See, you see, this air pollution also results into global warming, which global warming comes from an effect called greenhouse effect. See, what is that greenhouse effect? So, you see, there are gases here that are being produced due to burning fossil fuels in machines and vehicles and so on. These gases, like you have carbon dioxide. You have natural gases also that come from these fossil fuels, natural gases. See, natural gases, we have so many. See, natural means they come from nature. Methane, butane, ethane, propane, hydrogen sulfide are all natural gases. See, those gases, carbon dioxide. Now, we are seeing that one of the effects of air pollution is global warming due to greenhouse effect. See, now the word greenhouse, see, now somebody would be, you wonder, greenhouse. Anybody with the knowledge on what is it that causes what we call a global? Global warm is to warm the globe, not so? Yeah, that's why the increasing temperatures the increasing temperatures, you sleep in the house as if they have put a charcoal stove in the house. See, because bush fires are starting. See, the world is hotter than it would be. So now, how can guide? What is greenhouse effect? So, greenhouse effect is a term that was picked by one scientist many years back, 1804, and it was derived from the fact that when some green plants, which are very tender, very soft, cannot sustain to stay in very strong sunlight, are kept in special houses called greenhouses. And those greenhouses have been designed in a special way that when sun's rays enter them, they don't permit that warmth to leave them. And that warming that is captured by those greenhouses is what we call a greenhouse effect. And this same term has now been extended to being used by various scientists now and also ordinary people. Now, we said that greenhouse effect results into global warming. On Earth here, the word greenhouse effect means that the capturing of sun's rays, sun's heat by some gases which have special characteristics, and these gases are called greenhouse gases. And they include carbon dioxide, chlorofluorocarbons, natural gas. These gases have the ability to capture sun's heat and they don't allow it to leave the earth. And by so doing, the earth warms up than normal. That greenhouse effect fact here is what is causing that warming that we are calling global warming. See, now we are saying that reduce global warming here is to avoid burning fossil fuels. And we can't avoid it, but we can reduce their consumption. These fossil fuels are the ones that liberate these greenhouse gases. Now reduction in them reduces global warming. Otherwise, continuous use of these fuels are from coal, petroleum, natural gas. See, petroleum gives us fuels like petrol, diesel, kerosene, etc. all produce greenhouse gases. Now, still we are on our part of air pollution here, and the last subtopic here is eliminating air pollution. How do we do away with air pollution? You had some suggestions, class, which you discussed. What did we say you can eliminate air pollution? How could we achieve that? Yes, patience.
By carrying out afforestation.
We carry out afforestation. What's afforestation, patience?
Afforestation is like replanting of trees where they have ever been.
Yeah, that's planting of trees more and more in places that they have been already. Yes, afforestation, what does it really do? It is used to absorb these trees absorb some of these gases. What else, Aspolo, that you are trying to say?
Saying that we reduce the use of fossil fuels in the environment.
Thank you very much. That reduction on use of fossil fuels to reduce the production of greenhouse gases. What else that we would do?
By gazetting areas where industries can be carried out.
Yes.
Industrial activities can be carried out.
Thank you very much. That limiting places for industries, particularly for industrial activities, not industries to be placed everywhere. Is that the only thing? Do you have more? Oh, thank you very much. I think those were the key ways of eliminating air pollution. Now, in short, in summary, we have discussed over. We started with air. We said, looked at what's the meaning of air. We said it's just the atmosphere. Then we went to components of air, and there were very many. Then we also looked at the uses of various components of air. Then we went forward to looking at how we can separate air into various components. Then finally we now went to air pollution. Then we have exhausted the definition of air pollution, signs of air pollution, causes of air pollution, effects of air pollution, then eliminating air pollution. Now, there is an activity of integration here. That's the summary that I would like you to take down, and we shall mark it. It goes like this: activity of integration. Air pollution is becoming an increasing concern. An increasing concern. An increasing concern as we learn about the health effects. As we learn about the health effects of poor air quality, in Kampala. Of poor air quality in Kampala. Imagine you are an environmental engineer. Imagine you are an environmental engineer and you are given a contract. An environmental engineer and you are given a contract to sensitize the community of Kampala City of Kampala City Council Authority. Of Kampala City Council Authority about the quality of air. Prepare a radio talk show. Prepare a radio talk show outlining the source and effect of air pollution. Outlining the source and effect of air pollution on people and their environment. On people and their environment. And what should be best done to prevent and clean it up. And what should be best done to prevent and clean it up. Then full stop. Also indicate what the people must know about the composition of air. What the people must know about the composition of air. And the chemicals to determine how to mitigate. And the chemicals to determine how to mitigate poor air quality. Poor air quality. Thank you very much. We meet in the next lesson.